I'm excited to introduce today's presenters. We have Brent Schiestl, Senior Director of Product Management, Johan Carlson, Senior Product Manager, Gerhard Kruger, Senior Director of Sales Engineering, Hassan Shah, Senior Product Manager, and Chris Perez, Director of Product Marketing, Media, and Gaming. And with that, I will pass it over to Chris.
All right, thanks, Jonathan, and hello, everybody. Welcome to our annual What's New and What's Next webinar. So this has actually become our most popular webinar. So as we package up all the great features here we've released across the Helix Core platform and all the products we designed for digital creation and collaboration. That's for those building a game, working on visual effects for a film or an animated show, even those doing chip design or embedded software development. We got solutions for you. So I'm joined today by the great product leaders for each of these tools, and this at-a-glance view offers a brief summary of what we released over the year. But let's just go ahead and dive into those. We'll also be looking at what each of our product managers is planning next, so stay tuned for each of those sections. All right, let's get started. Britt, you want to talk to us about Helix Core Cloud?
Yeah, thanks, Chris. So Helix Core Cloud, for those of you who may not be familiar with it, is Perforce hosted and managed version control. It's the same Helix Core you're used to using in your daily life, but we manage it for you and host it for you, which means you get out of the business of being the administrator and having to worry about things like upgrades. And so let's dive in. Helix Core Cloud, again, managed and versioned by us. It's available for a monthly fee, $39 per user per month. It is designed right now for teams that are under 50 users. You can see it's turnkey, single tenant, so don't worry about those noisy neighbors. You get a base amount of storage, and then you get a base amount of egress per month. Since original launch in January of last year, what we did was we added multi-region support. So we got a lot of demand from customers saying, hey, I know you guys are supporting US in terms of where the VM gets deployed, but I'm located elsewhere. So we added support for UE West in the European Union, as also in the UK. So now when you sign up for Helix Core Cloud, you can choose your preferred deployment region. We also increased the max storage capacity from 2 TB to 32 TB. And then we recently added Helix Swarm for code review. And so I'll show you what that looks like. Again, when you come into Helix Core Cloud and you go to manage your subscription, you can change the number of users, you can add additional storage, and then also now we have this new section called additional features. Helix Swarm is only available for customers with at least 3 subscribed Helix Core users. And we do that just to make sure that it makes sense for people to have enough folks on their team to require a systematic code review. And again, the key here on the right-hand side, it is free. So we're not charging extra for Helix Swarm. It's a free offering, a free add-on. So if you want to add code review into Helix Core Cloud, you can do that anytime. Now I'm going to move on to Helix Core itself and talk about some of the enhancements we put in 2024. So we're going to start with this topic of Delta transfer. This applies to binary files that are stored uncompressed, which means the binary plus F file type in Helix Core. And this was added in 24.1 for submit. So there's 2 graphics here. This one on the left is kind of the historical logic. So what existed in the system prior to our release in 24.1. And you'll see here kind of 2 scenarios. You have a client on the left and a server on the right. And when you go to add a file and do the initial submission, we need to transfer that entire file. In the past, when you made a change to a file, and in this case, we were just illustrating this sun in the original file change to a cloud. And historical logic would say we send that entire file again on the submit process. So the client is transferring the entire file over to the server. On the right-hand side, you see the new logic. There's nothing changed in that initial file add and submit process. We still need to submit the entire file. But now you'll see when a subsequent edit is made, and again, this sun is turned into a cloud, now we're sending approximately only the cloud portion of the change from the client to the server. And so what does that mean? It means the server already has a version of this file, and the server is able to detect what is the difference, right? And when it gets its small piece of it sent from the client, it's able to regenerate that file. And what that means is, especially for submit, when you're using upload capabilities, oftentimes your upload speeds are worse than your download speeds, especially when you're working remotely. If you have low bandwidth connection or you have high latency between the client and the server, those are all scenarios where we expect you to see some benefits from this new logic. Also, it behooves us to say that the larger the file and the smaller the change, the more performance gains you're probably going to see from this functionality. So again, this is 24.1 added for submit functionality. Now, if we look at 24.2, which came out in November of this year, we extended this logic and said, let's do this for syncs as well. And so now it's, instead of the client transferring data to the server, this is the server transferring client data to the client. And again, in the historical logic, somehow I got moved to the right, sorry about that. In the right-hand side, the historical logic was, actually it's just the labels that got messed up. So on the left-hand side is the historical, sorry. And what you see here is that the entire file gets sent on the initial sync, and that's because the client doesn't have anything. And then on a subsequent sync, we used to send the entire file again, no matter what the change was. With the new logic on the right-hand side, you'll see, again, the initial sync, we have to send the whole file because the client doesn't have any version of that file. But now when we're doing a subsequent sync and we're just syncing a new revision of that file, we can detect, well, what is the change that was made? What is the difference between the version the client currently has and the new version we're sending? And we can send just those differences back to the client. And now the client is responsible for regenerating that file. And so again, all about sending less data. And again, the larger the file, the smaller the changes that have been made between the revisions that the client is asking for versus the revision that the client has, the more gains we expect you to see with this logic. We also have some configurables to control this logic on both the client and the server. So encourage you to read up on this in the release notes. You'll be able to see what those configurables do and how they can tweak the behavior. The next thing I want to talk about is lightweight branching. So we added something called sparse streams. So this applies to customers that are using streams for their branching. A lot of scenarios where you want to potentially create a stream or a branch per bug, a branch per feature, or a branch per release. And again, these are scenarios where you might not have a lot of divergence from the child stream compared to its parent. When you're working on a small bug or a small feature, you're not maybe changing all of the files in that stream. You're only changing a small percentage of them. That bodes well for sparse streams. And sparse streams introduces a new method for creating branches and optimizing the creation of those branches. Number one, it instantaneously adds the branch. Number two, it reduces the amount of data that we store per branch because all we're doing is branching files on a per file basis. So when you go into that sparse child stream and you open for edit a file, only at that time will we branch the file if it hasn't already been branched locally into that new sparse stream. The rest of the files that are not being changed in the sparse stream are never branched into that stream. And we use something called overlay mappings or overlay views in order to make the stream appear like all of those files live there. And all of this is saving time and resources. So no longer are you doing that heavy populate step. And obviously, the more files you have in that child stream, the more savings you're going to have in terms of the amount of metadata that is not being created, where traditionally we would populate metadata for every single file in the parent stream into the child. So that is lightweight branching, and it was added in the 2024.1 release of Helix Core. And then we followed up with an enhancement in 2024.2 because originally we had a limitation that you couldn't unshelve files into a sparse stream. And so in 2024.2, which again was in November, we eliminated that restriction, and now you can unshelve into a sparse stream. The next enhancement I want to talk about is virtual file sync. You may know of P4VFS, which is a new client that can be added to Windows desktops or Windows clients, Windows PCs. So virtual file sync is not supported on Mac OS clients or on Linux clients. it was introduced all the way back in actually 2023.1. But what we did in 2024.2 was enhance it, and we added support for something that we call hot files. So this graphic that you're seeing is showing, hey, with this new sync logic, this virtual sync logic, all we're doing is syncing down metadata on the initial request. But some files, and a good example here is text files, aren't going to benefit greatly from being virtually synced because they're not really large in nature. And so by only syncing the metadata, we're not really saving much as if we would have just synced the entire file. So what you can do now is you can define what are called hot file rules. Okay, so a hot file, again, is never virtually synced. It's always just traditionally synced. So we're going to sync both the metadata and the file content. And a hot file rule is some combination of a depot path, which is required, and if desired, you can put in a file type and or a file size. So a good example here is saying, here's a depot path, and I only want it to be considered a hot file if it's typed as text plus capital C, and it should be less than 100K. So that would say anytime we evaluate a sync, we're using one of these alt sync clients, which opts into the VFS behavior, we are going to evaluate these rules and say, if these rules are true for any of the files, don't do that virtual sync, just do the traditional sync. So then you're going to get a mix of files that are actually synced on disk, the full content, and some that are just stubs on your local file system. And it kind of gives you the best of both worlds. It's not having you pay that eventual tax if you're actually wanting to sync those small files. Instead, you just pay it up front. And again, best of both worlds, some virtual, some fully synced, and you get to control how that all works. Those rules are defined on both the server and can be overridden on the client. So giving ultimate flexibility to you in terms of how you want to define them. And if individuals have different preferences, you can accommodate those. And then I want to also just mention that S3 storage was introduced originally into the 2023 release, 2023.2 release for archive depots. And again, when we say it's S3 support, it doesn't have to be AWS. It can work with any cloud provider that has S3 compatible APIs. But I do want to call out that this does not apply to Azure Blob Storage. What I do want to call out for 2024 is that in the 2024.1 release, which was May of last year, we expanded our S3 support to both local and streams depots. So if you want to have operational data and you want to back it by S3 because you find that the cost benefits outweigh any potential performance impacts or offsets, we're giving you the ultimate flexibility to make those decisions. And so again, if you want to back a local or a streams depot with S3, you can now do it as of the Helix Core 2024.1 release. And then I just want to give a quick sneak peek to what's coming in May of this year, May of 2025. So you're seeing these diagrams. You're going to see a very similar diagram, except this time in our diagrams, we don't have client and server. We have an upstream server and a downstream server. And again, in today's world, when we're replicating data, for instance, from a commit server down to an edge server, for those of you using edge servers for geo scale and just general scale, today we always replicate every file and every full file. So in the initial replication, we send everything. When a change is made and we're replicating a new version of a file that is already on that downstream server, we replicate the entire file. With 25.1, what we're working on is, again, the initial replication, we have to send the entire file because the downstream server doesn't have it. But subsequently, when a change is made, we can replicate only that change, and the downstream server is going to regenerate that file. It's, again, only applying to these binary plus F files. So make sure that you're using that file type to get these enhancements and these advantages. But again, replicating less data, it just feels like the right thing to do because we're going to spend less time filling up the pipes and we're going to allocate bandwidth for other purposes between that commit and the edge in this hypothetical example. The other things coming in 25.1 include replica improvements. So we're focusing right now on pull thread transparency and just making sure that we can make it easier to troubleshoot if a given file was not successfully replicated from the commit to the edge, that we're giving you full transparency into fixing those problems and giving you more tools in your tool belt to understand where things didn't replicate, and making sure that we can help you out of those scenarios. And then the last thing we're working on right now is speeding up the reconcile command. So we're looking at ways to, number one, just do less work. Number two, we're going to make move detection optional. Number three is not going to necessarily speed it up, but we're going to add progress reporting. So if you're doing a reconcile command in P4V, eventually you're going to see a progress meter like you see for sync and submit today. So those are some highlights of what to look for 25.1, which will be May of this year. And then last, I'm going to tease an announcement that we're going to make at the Game Developer Conference this year, which is in March in San Francisco. If you're there, stay tuned. We're going to have an acquisition announcement that we're going to talk through, and a new way of working with Helix Core that we're going to demo as part of GDC. If you can't make it to GDC, just stay tuned to our website. We're going to have everything there as well. But we're very excited to open up new ways of working with Helix Core.